Okay guys, graphical solution of linear simultaneous equations. It sounds like a nightmare, doesn't it? Actually, it's really great fun and it's very simple. So let's make a start. The graphical solution to two linear equations, which means straight line equations, if you draw them on a graph they're a straight line, is the point where the rule simultaneously, that means at the same time if you like, applies to both equations. Now, what does that mean? Well, that is the point on the graph which we are looking for is on both lines. Both lines, okay? This is the point at which they cross or intersect, because that point is the point where both rules are working at the same point, right? Our value of x, the y values will work for both equations and they will be the same simultaneously. Let's have a look at this in a bit more detail. NB. To obtain accurate answers, we must draw accurate graphs on graph paper. Otherwise, anything could happen really. It won't be very accurate. The procedure, okay, the procedure. What do you do? First of all, you sketch each linear graph accurately on graph paper. Yes? Secondly, you find the point where they intersect. Okay, that means where they cross. Thirdly, you then identify the x and the y coordinates at this point of intersection. These two values are the solutions of what's called the simultaneous linear equation or equations. Fourthly, if the lines are parallel, that means like train tracks or tram tracks, they're running in exactly the same direction. Well then, in that situation, as if they also have different y-intercepts, that means they're offset from each other, then there are no solutions because the lines never ever meet or intersect. That's the sort of like the exceptional situation, okay? But if the gradients are different, then sooner or later, guys and gals, they are going to meet, okay? Different gradients means different steepnesses, right? That means yes, they will meet, and there will be a solution to the simultaneous equations. Now let's do some and just see how this all works. That's the best way to learn, is by doing. Use the graph of the given simultaneous equations below to determine the point of intersection and hence the solution of the simultaneous equations. Right, so the first thing I do is I label them. I call that first equation equation 1, the second equation equation 2, and now our job now is to basically find where these lines go on a graph and then to find where they intersect, and that is the answer. That is the answer. So take equation 1. I'm going to work out where they go by using the intercept method. In other words, I'll find where the x-intercept is, the y-intercept is. That gives me 2 points, and then I just run the line through those 2 points, because you only need 2 points to do a straight line graph. Okay, so for the first one, when x is 0, so you make x is 0 in that equation, and then you will get 2y is 4, and therefore y is 2. That's the y-intercept, yep. And then also when y is 0, that means in that first equation, that'll be x plus 2 times 0 equals 4, and therefore x will be 4. That's the x-intercept. Now equation 2. Same procedure. Okay, you say when x is 0, y would be minus 3. Do you get that? Look at the equation 2 here, and just you can see that that works. Okay, when x is 0, y will be minus 3. You get it? Right. Now, that's the y-intercept. When y is 0, okay, when y is 0, that's 0. So you then have to solve that for x. So 2x minus 3 will equal 0, and therefore you have to start doing a bit of algebraic manipulation to get x, and you get 2x is 3, and therefore x will be 3 over 2, or 1.5, which is the x-intercept, right? Now here we go. There's our graph grids. Let's put these points on there. That's from equation 1, isn't it? Yeah, that's from equation 1. This is the y-intercept, which we got was here. Y was 2. And this one here is your x-intercept here, where y was 0, x is 4. Now, if you put a line through that, There's your straight line graph, which belongs to equation 1. Now you do the same thing for equation 2. Now that's equation 1, nicely labelled. Equation 2, there's my two intercepts there. So the first intercept was when x is 1.5. The second intercept, the y-intercept, was where y equaled -3. And you can see, look, bonanza, there's where they intersect. That is the point at which both of those rules work. Both of them. For this value of x here, which looks like, what is it? X is 2, y is 1. So that is the point that I want, and that is the solution to my simultaneous equations, where the lines intersect, x is 2, y is 1. That's my answer, guys. Do you get it? It's as simple as that. Here's another one. Let's do this one. For the following simultaneous equations, use substitution to check if the given pair of coordinates... Oh, we have to check if the given pair of coordinates, this one, x is 5 and y is -2, is a solution to this and to this. Okay, we don't have to draw a graph here. They're giving us a proposed solution. We have to see if this value of x and this value of y works in this equation and in this equation. So we have to see if 3 times 5 minus 2 times -2 comes to 19, and whether 4 times -2 plus 5 comes to -3. Now, I'll bet you what you like it does. Take equation 1, let's test. Substitute x is 5, y is -2 into that equation. Now, on the left-hand side is 3x minus 2y, so it's 3x, where x is 5, minus 2 times -2. Be careful of that one. Negative times a negative gets you a plus, yeah. So that gets you 15 plus 4, which is 19. Oh, look, that's the same as the right-hand side. Isn't that great? So it did work in equation 1. Now we have to just test it out in equation 2, and if it does work, we're laughing. Yes, equation 2. Now substituting x is 5, y is -2 again. So 4 times y, which is -2, plus x, which was 5. That's the left-hand side of equation 2. Now what's that come to? -8 plus 5. -8 plus 5 is -3. Ooh, goody. That works. See? That's the same as the right-hand side. So everything did work. That value of x and y simultaneously works in both of those equations. So yes, we have shown it, that it is a solution. Okay? Alright, onward ever onward. Solve the following pair of simultaneous equations using a graphical method. We have to do a graph for this one. But we know what to do, don't we? Because we did it in the first example, so we just do the same thing again in this example, and we can get our solution by drawing the graph, finding the point of intersection of the two graphs, presuming they're not parallel. In which case there'd be no solution, would there? Right, equation 1, equation 2, label them. Take equation 1. Now, when x is 0, y will be 6, won't it? See there? Yes, that's the y-intercept. And when y is 0, what will x be? You have a look. Yes, it'll be 6. So that's my x-intercept. Good, that takes care of equation 1. Now here's equation 2. And we've got to do the same thing there. When x is 0, have a look. 4y would be 20, therefore y would be 5. And that's my y-intercept. And when y is 0, we've got 2x equals 20, therefore x equals 10, and that's my x-intercept for equation 2. Let's draw the graph now. Now here comes these intercepts. That's the situation for the first equation. Y-intercept was 6, x-intercept was 6, good, and we'll put the line in, there it goes. Now for equation 2, oh, look at that, beautiful. Equation 2, when is that right? Equation 2, when x is 0, y was 5. That's right, that's the y-intercept. And when y was 0, x was 10. That's right, that's good. Okay, everything's good. Now, this is our solution, guys. This point here, this is where they meet. Look. So what's x and what's y? You read it off and then I'll confirm. Okay, good. 2 and 4. So that is the solution. That's the point of intersection. That's what POI means. Point of intersection is 2 and 4. So x is 2 and y is 4. and we're feeling great. Yeah, that's it. That's what you do. Oh yes, for parallel lines, I thought I'd put something in here for you about parallel lines. It is possible for two simultaneous linear equations to have no solution. You can see over here, look, they're parallel. There's never ever going to be any point where they meet because they're running in exactly the same direction. That is, they have the same gradient. Okay, so this occurs when the graphs of the two equations do not cross because they have the same gradient. In other words, the two graphs are parallel. That's the situation. So in this particular pair of simultaneous equations, they are parallel. Yeah, they are parallel. They are parallel. If you solve that for y equals mx plus c in that form, you would get, for this one, you get y equals 2x minus 5, and in this one you would get 2y equals 4x minus 6. And if you divide through that one by 2, you'd get exactly the same equation as we got up here. So therefore, oh no, you wouldn't. You'd get the same gradient but a different y-intercept. Yeah, that's right. What did I say? 2y equals 4x minus 6, therefore y would be 2x minus 3. In this case, y was 2x minus 5. Yeah, so they have the same gradient of 2, but different y-intercepts. That's what they've got. And therefore they can be graphed as these kind of parallel lines, and you can see there's no solution. No solution at all, okay? You understand? Good. Now, this is the summary, this is the end. So, when solving simultaneous equations graphically, you obtain an accurate solution by doing it on graph paper. The solution to the linear simultaneous equations is the point where their graphs intersect. Lines that have the same gradient are parallel and do not intersect. So, there's no solution for them. If the graphs of the two simultaneous equations are parallel lines, then the simultaneous equations have no solution as they have no point of intersection, which is what we just said. Okay, are you happy? Well, you go off and do lots of practice because you're a star. Okay, and we'll see you in the next exciting video. Have a wonderful day.